we're going to be dealing with problem 5.7. So for the circuit shown in the figure 5.26, assume V is equal to 50. So we have to determine VO, IB, and IC. For VI is equal to 0.2. So we're given VBE on as 0.7 volts and VCE to be 0.2 volts. So when we look at the figure, we can see that the arrow is pointing outwards, so which means this is a NPN transistor. So this is NPN, and then we're going to have IB in this direction, IB right here, and then we're going to have IC, the collector current, coming in right here. So we're going to start with calculating IB. So we're going to do that. So we're going to say 5.7 A. So calculating IB. So we know that IB is calculated using this formula. So IB is equal to VI minus VBE on divided by the resistor in between, which is RB. So before we do the calculation, we have to check something. So we have to check if VI is greater than VBE. So when we look at VI is 0.2. So there's it. So we have VI as 0.2 volts, and then VBE is 0.7. So VBE on is equal to 0.7 volts. So VI is less than VBE on, which means that IB will be 0. So we're going to say IB is equal to 0 amperes. And if IB is equal to 0 amperes, IC also will be 0 amperes, because VI is less than VBE on. So IC is also 0 amperes. So there is no current there and there is no current there. So now that we found IB and IC, now we can find the voltage VO, that voltage right there. So to find that voltage, so we're going to say VO is equal to 5 volts. So we have V positive right there. So V positive, which is 5 volts, minus IC, multiply that by the resistor RC. So now we know that IC is equal to 0 amperes. So we're going to have 5 minus 0, and then VO is equal to 5 volts. So we are done with part A. So we have, let's check the answer. So we have IB, IC also equal to 0, and then VO is equal to 5 volts. So now we have to find the power dissipated in the transistor. So to find the power dissipated in the transistor, we need IC and VCE. So let's do it. So P transistor. So we have IC, multiply that by VCE. So we do have VCE, so which is 0.2, but IC is equal to 0 amperes. So PT will be equal to 0 watts. So now we're going to move on to 5.7b. So in part B, we're given that VI is equal to 3.6. So we're going to start by finding IB. So we're going to use this equation. IB is equal to VI minus VBE on divided by the resistor in between RB. And all of that is equal to, so first of all, let's check the values of VI and VBE. So VI is equal to 3.6 volts, and then we have VBE, which is equal to 0.7. So we can see that VI is greater than VBE on. So now we can use this formula to calculate IB. So IB is not equal to 0. So we're going to say 3.6 minus 0.7 divided by 640. And this gives us 4.53 milliamperes. So moving on, we have to find IC. So we're going to use this value right here to find IC. So IC is equal to that value, multiply that by IB. So this is equal to 50, multiply that by IB, which is 4.53, multiply that by 10 to the power of -3. And this gives us 0.23 amperes. So moving on, we have to find VO. So let's go ahead and do that. So VO is equal to V positive, which is 5, minus IC, multiply that by RC. So we already have IC, so we're just going to plug that into our equation. So we have VO is equals to 5 minus IC, which is 0.23. So I just rounded that off. So this was usually 2.265 amperes. So I'm just going to use that value. So I'm going to say 2.265 and then multiply that by RC. So where is RC? So RC is equal to 440. So we're going to multiply that by 440, and then we're going to have VO is equal to, and this gives us negative 94.66 volt. So there's something that we have to note here. So VO in this case, so VO is equal to VCE. So right here we just calculated VCE, but when you look at this VCE, so let me just write it right here. So this is equal to VCE, but we have to note that this VCE is less than VCE saturated. So we have VCE saturated given in this question. So we have, where is it? Yeah, right here, VCE saturated, which is 0.2 volts, and what we just calculated is VC, and it's less than VCE saturated because it's negative 94.66 volt. So what we have to note is that in a common emitter configuration of a NPN transistor, VCE cannot be negative. So this means now IC that we calculated was wrong. So that IC is wrong. So now we have to recalculate IC. So we're going to use this equation. So IC is equal to V positive minus VCE saturated divided by the resistor in between, which is RC. So IC is equal to 5 minus VCE saturated is 0.2 divided by the resistor in between, which is 440, and this will be 0.011 amperes. So when we have VCE, this VCE being less than VCE saturated, we have to recalculate IC, and then we can also say that VO, we can also say that this is equal to V positive minus VO divided by the resistor in between. So we have VCE saturated is equal to VO. So only when this condition is met, then we say VO is equal to VCE saturated. So now we have to calculate the power dissipated by the transistor. So we have PT is equal to IB, multiply that by VBE on plus IC, multiply that by VCE saturated. So IB, we calculated it previously, so we have 0.22, no, not this one. So we have this one, 4.53 milliamperes. So we're going to write that down. So we're going to have 4.53 multiplied by 10 to the power of -3. Multiply that by VBE on. So VBE on is equal to 3.6 plus IC. So IC is 0.2265. Multiply that by VCE saturated, which is 0.2. Okay, looks like I'm getting a weird answer, so let's look into that. So let's see. Okay, oh, okay, I used a wrong IC, so I have to use this IC right here, not the one we just neglected. So I have to use this one right here, and then 0.11. And also for VBE, I used the wrong value, so that should be 0.7. So that should be 0.7. So calculating that, we get 5.37 milliwatts. And that's it for 5.7. So now moving on to 5.8. So we have to determine VI such that VBC is equal to 0. So there are a few things we need to know. So we must know that VCE is equal to VO. And we're going to say VCE is equal to VBE plus VBC. So to find VCE, so we're going to say VCE, and then we're going to substitute the values that we have into this equation. So VBE, so VBE is 0.7 right there. So we're going to have 0.7 plus VBC. So VBC is 0. So we're going to have 0. So basically VCE is equal to let me say VO is equal to 0.7 volts. So now that I have VO and that power source right there, so I have VO and that power source right there, I can find IC. So I'm going to find IC right here. So I'm going to say IC is equal to 5 minus 0.7 divided by the resistor in between, which is 440 ohms. So I'm going to say IC is equal to 9.77 milliamperes. So now that I have IC, I can find IB using IC and this value right here. So IC is equal to this value, multiply that by IB, and now we have 50, multiply that by IB, and then IC is equal to 9.77 multiplied by 10 to the power of -3. So what I have to do now is to divide both sides by 50, divide both sides by 50, and then I'll get IB, which is 0.195 milliamperes. Or you could say IB is equal to 195 microamperes. So now that I have IB, so I have IB and then I have VBE on, and then I also have the resistor right there. I can find VI. So let's go ahead and do that. So I'm going to use this formula. I'm going to say IB is equal to VI minus VBE on divided by the resistor in between, which is RB. So IB is equal to 0.195 multiplied that by 10 to the power of -3 is equal to VI, of which is what we are looking for, and then minus VBE, which is 0.7 divided by RB, which is 640. So we have 640. So what I'm going to do now is to multiply both sides by 640, and I'm going to get something like so I'm going to get 0.125 this side, and then I'm going to have VI minus 0.7. So I'm going to say that 0.125 plus 0.7, and then I'm gonna get VI is equal to 0.825 volts.